an earlier speaker. If we take the more recent period, so I've broken this figure up into two time periods. The lower right is 2001 to 2006. The upper left is the 1990s. And what I'll just point out is that at the margin, we are emitting twice as much CO2 per unit of GDP in the more recent period than in the 1990s. So in the post-Kyoto period, when the world has been the most concerned about climate change and carbon policy, we've been moving rapidly in the wrong direction. So we can take this curve, this is the global decarbonization curve, and say, what would this have to look like if we wanted to reduce emissions by 80% by 2050? And because I presented you the Kaya identity, you know, well, we have to specify a GDP growth rate. I don't know what future GDP is going to be, so I'm going to give you a range of choices from 1% to 5%. Here's what that curve looks like. The average world GDP was 3.5%. You can use that as an anchoring device to think. It doesn't really matter. You can see they're all very low. I haven't given you any basis for understanding what that means. All right, so we go from 0.62 to below 0.1. Is that low? Is that significant? I'll get there. So this is just what that curve would have to look like at the midpoint, 3% reduction. So let's be specific and start talking about carbon dioxide emissions in different countries. So this is Germany, Japan, US, and China. There should be nothing surprising here. Japan has a very carbon efficient, also very energy efficient economy. Germany also very efficient. US less so, and China even less so. If we set each of these countries equal to 1 in 1991, which I picked simply because that's the year of German reunification, there's some interesting things. One is that Japan hasn't improved. Even though it's very efficient at a very low level, it hasn't improved. Raises some questions that are interesting from an academic perspective, but also a policy perspective. Are there limits to efficiency gains? Germany and the United States, they start at different places, but their rate of decarbonization has been identical over 15 years, which is fairly remarkable given the difference in politics in Germany and the US. China saw very rapid decarbonization as its economy boomed in the era of globalization, and then it started recarbonizing. You probably have heard the vignette, the anecdote of China bringing online 2 coal plants a week during this decade. You see that in this J-hook of this curve, and this actually helps to explain why the global rate of decarbonization slowed a great deal in the current decade. Now, I'm going to talk about the United Kingdom Climate Change Act. This is for a couple reasons. One is I lived in the UK in 2007 while I was on sabbatical. The other is the UK has really been a leader in climate policy. And when you're a leader, you get a lot of applause and kudos, but policy analysts gather around like flies to evaluate your policies. And so that's what I've done here. The UK has 2 targets. It has a short-term target for 2020, which is really 2022. It's over a time period, and a long-term target for 2050. The short-term target is, they have 2 targets. One is 42%, you see here, but that's if the world agrees % reduction by 2020, and that's the one I'll evaluate. So here's the historical decarbonization of the United Kingdom. Like most large developed economies, it has been improving. And you see it's actually near Japan. It's a very carbon efficient economy for reasons I'll explain in just a second. The reason for this is that the nature of the UK economy has been shifting. These curves show manufacturing, trends in manufacturing in the UK. The top is GDP and the bottom is employment. And a lot of the UK economy has been shifting to services. A lot of that manufacturing has been actually moving to China and elsewhere. So there are valid arguments about whether some of those emissions should be accounted to the UK. The point I would make is that decarbonization through sectoral shifts like this aren't really sustainable over the long term. Once manufacturing gets to 0, you have to try something else. Now, we can ask the policy question. What would this curve look like if the UK seeks to reduce emissions 80% by 2050 or 34% by 2022? Again, we have to specify a rate of GDP growth. Here's what the long term looks like, and it's down to about 0.05. I still haven't given you a measuring stick for evaluating that. Here's the short term targets, down below about 0.20. And then if you put these 2 together, you see that even if the short term target was met, it is not as ambitious as the longer term target. So I'm going to give you a measuring stick, and that measuring stick is a country called France. France has 0.3 tons of CO2 per $1,000 GDP in 2006, the most carbon efficient large economy in the world because it relies so much on nuclear power. This shows the electricity generation in France. Yellow is nuclear power, and you see that's been expanding. And I should point out, the French commitment to nuclear power has nothing to do with carbon policy or climate policies. This is decarbonization in France. France actually has not decarbonized at a very fast rate. But one thing we could do is say, at what point in time was France at the level of the UK? And how long did it take to get to 0.3? So it was 20 years. So we know it's possible to go from where the UK is in 2006 to where France is. And to get to those very low levels, you have to go through the French level at 0.30. And the policy question is, can we do this faster than 20 years? So I put on this graph, this is returning to the UK decarbonization short-term target. I put France up there as that big red dot in 2006. If we were to drag that red dot from the left to the right and see where it intersects these curves, then we would know at what point in time, going down to the x-axis, the UK would have to be as carbon efficient as France. And again, it depends on GDP growth rate. But at the latest here, for a 1% annual growth, and if it is only 1% annual growth in the UK, there will be some very upset citizens and governments will change. But at the very latest, it would be about 2015 or 2016. Now, what does this mean in real numbers, in practice? What this means is that the UK would have to accomplish the equivalent level of effort. So this is just a measuring stick of building 30 new nuclear power plants, putting them into service, and retiring an equal amount of coal and gas electricity generation by 2016. I've gone out on a limb, I think it's a pretty sturdy limb, and said this is not going to happen. The UK government has produced a very thick volume that explains all sorts of changes across sectors. There will be 1.7 million electric plug-in cars. There will be insulation put on roofs in houses, and people will change their lifestyles. To my mind, spreading it around sectors just makes it much more of a challenge. And it's still the level of effort equivalent to building 30 new nuclear power plants. So this is how it looks in the big picture. I gave a talk at Aston University in the UK earlier this year. I was interviewed by the BBC, and one of the advantages of getting interviewed is that they ask other people, what do you think about these sorts of studies? And Colin Challen, who's a member of the UK Parliament, he's the chairman of the All-Party Parliamentary Climate Change Group responsible for climate policy, had this to say. He said, Pielke's analysis raises questions which I do not think have been factored into the thinking behind the Climate Change Act. The task of cutting emissions by 80% from 1990 levels is already staggeringly huge, and as we have seen, well beyond our current political capacity to deliver. A progress report was just put out last week by the UK Climate Change Committee that said that there has been no change in the rate of decarbonization. At the bottom there it says Heathrow is a prime example. There's a big debate in the UK about building a third runway at Heathrow Airport, and it's contested. To put that in perspective, China is planning by 2020 to build 70 new airports. So it is largely of, I think, symbolic value. This is using our French measuring stick, looking at the global curve. So the world would have to be as carbon efficient as France by about 2018. Again, a very sobering prospect. I have numbers for the US, and in the interest of time, I'm just going to skip. I'll flash these by you, and perhaps we can discuss these. One of the things I tell my students this week actually are doing this for the top 20 emitting countries. And one of the lessons that we have gotten from this exercise is that we can't get there from here. We do not know how to achieve emissions reductions goals because the magnitude of the challenge simply can't be met with technologies we have today. So how fast can decarbonization occur? The honest answer is that nobody knows. We're talking about rates of decarbonization that have never been accomplished anywhere for a sustained amount of time in order to reach these emissions targets.